Photoelectric effect. Photoelectric effect is a phenomena of ejection of electron from a metal surface when the metal surface is illuminated by a light of frequency greater than a certain frequency, and this particular certain frequency above which the photoelectric effect take place is called threshold frequency, and the corresponding energy of the light is called threshold energy. Now, before going into photoelectric effect, let us understand something about the atom and the electron revolving around, how we can remove an electron from an atom. Now, here you have an electron and a nucleus. This electron being a negatively charged and the nucleus being positively charged, there is a force of attraction between this electron and nucleus, and with respect to this force of attraction there will be a energy by which this electron is bound to this nucleus. Let us take that energy to be minus E naught. This minus sign indicates the electron is bound to the nucleus. Now this means that if we are able to provide an energy equivalent to plus E naught, this electron can be removed. Now you can give this energy E naught either by thermal energy, that means by heating, or by using light. Now if you are giving thermal energy, which is a continuous form of energy, that means you keep gradually giving the energy, and when the energy reaches plus E naught, this electron will be removed, and the energy required to remove this electron is called ionization energy, because by doing that we are making this atom an ion, removal of an electron. Now what happens when we use light? This is what is called photoelectric effect. Now coming to photoelectric effect, here we have a metal surface. This is the metal surface, and on the metal surface we have an atom where this electron is bound to this nucleus, and this energy by which this electron is bound to nucleus is, we have taken it as minus E naught, and let me call that name by work function. Work function of the metal, let it be phi. Now suppose there is an incoming light beam falling on this metal surface with an energy equal to h nu. If we have to remove this electron, if this light beam has to remove this electron from this metal surface, the energy of this incoming light beam must be greater than the work function. That means h nu must be greater than work function, or equal to work function will be just removed, and the minimum energy possessed by this light beam so as to remove this electron is called threshold energy, as we have already discussed, threshold energy, and the corresponding frequency will be equal to threshold frequency. Threshold frequency nu naught. So we know that if it is equal to h nu, that is h nu is equal to phi, the electron will be just removed, and if it is greater than phi, that is the work function, it will be removed as well as it will be moving with some velocity. That means if the incoming energy h nu is greater than phi, the electron will be using the energy phi for removal of electron. Okay, this energy will be used by this electron to get detached from this nucleus, and the remaining energy, that is h nu minus phi, that means phi already used from h nu, and the h nu minus phi will be used by this electron to move, that is it will be using it as the kinetic energy of the electron, and this equation is given by Einstein. Let us see why classical mechanics was unable to explain the photoelectric effect. Here you have three different light beams with different energy, as we know, is falling on this metal surface one by one. Okay, and let us take the work function of this metal surface to be around 5 electron volt. Now we know that this work function is greater than the incoming light beam energy of each of them, so none of them separately cannot knock out this electron from this metal surface, because the energy of the incoming light beam is less than the work function, that is 5 electron volt. Now what happens when they together fall on this metal surface? They fall on this metal surface together at the same time. What happens? Can they knock out this electron? So when we add this energy of each beam, we have 1.77 plus 2.2 plus 3.1, which gives you 7.07 electron volt. So which is greater than 5 electron volt, which is the work function of this metal. Now, so far as per our knowledge of classical mechanics, this three waves together can knock out this electron. But this does not happen. That is the failure of classical mechanics. When they together fall, that means when they together fall means the intensity of the incident light beam is increasing. So when the intensity increases, the electron does not get removed. Problem that we face here is the three incoming incident light together have an energy equivalent to 7.07 electron volt, and it is falling on a metal surface whose work function is equal to 5 electron volt. Now when they fall together on this metal surface, why they are not able to knock out this electron from this metal surface, even though their energy is greater than the work function? This is what is something that the classical mechanics was unable to explain. Earlier we have seen when we gradually heat this atom, the electron gaining the ionization energy and the electron will get removed. But here in the case of photoelectric effect, as we gradually increase the intensity means number of light beams falling on the electron increases, this electron is still bound to this nucleus and it is not being knocked out. Now the reason is, when the light beam interact with this electron, they interact as particles. So photoelectric effect emphasis on the particle nature of the wave. So they interact with the electron as particle. The particle is called photon. And what is photon? Photon is nothing but a packet of energy or quanta of energy, and this gave rise to another branch of physics called quantum mechanics. Here are some more reasons why the classical mechanics was unable to explain the photoelectric emissions. For every metal, there is a threshold frequency below which no photoelectrons are emitted. Okay. Now, photoelectrons means the electrons which are being emitted by the photons. Now, above threshold frequency, the number of photoelectrons emitted is proportional to intensity. That means when you increase the intensity of the light beam is given by the wave, the amplitude of the wave. When the amplitude increases, the intensity increases. Now, when intensity increases means number of number of photons will be increased. These photons having the energy greater than the threshold energy will be removing the electrons, so number of photoelectrons also will be removed. Now, the photoelectric emission is an instantaneous process. This is another proof that the photons or the light waves interact with the electron as particles rather than wave. That means they interact one-to-one collisions. So the time lapse between them, that is the incident of the light and the emission of the electron, is just 10 to the power minus 9 seconds. Another reason, when intensity increases, the total energy of the light increases. As you know, the energy is proportional to the intensity. So the total energy of the light increases, but photoelectric effect does not occur. Light behaves as particle with certain quanta of energy. All this comes up to a conclusion that the light behaves as particle with certain quanta of energy. Here is the end of the part 1 of photoelectric effect. In the next video, we will be doing the experimental analysis of photoelectric effect. Here is our Telegram channel, CSIR Net IIT Jam Physics, where you can get the questions and notes regarding these exams. Thank you.